Hello, I'm going to go over number 2 for the Unit 4 practice exam. So on this one, we're going to be given a 1/4 kilogram mass. So M equals 1/4 kilograms. And units are important just to denote, just in case if you're working with SI or ANSI units. The reasoning is because if we're given a mass that is 1 pound, then we need to make sure that we say M equals 1 pound divided by G, which is 32 feet per second squared. So since we are in kilograms, that is our mass unit. But if we're working with ANSI units, we need to make sure we convert everything to slugs by dividing pound force or pound weight, however which way they like to denote it, divided by gravity, which is feet per second squared to get slugs. So that's attached to a spring with a stiffness, so K, which equals 8 newtons per meter. The damping coefficient, read that, it's blocked by the little thing. Coefficient is 2 newtons second per meter. I know someone asked me before, but this just means newtons times second divided by meter. It's just pretty much what you do to get a force unit because we're multiplying our b times velocity essentially to get newton. So that's why you have that second per meter, because you multiply by velocity, they'll cancel out by using meter per second, so you just get newtons. Mass is then pulled down 1 meter from the equilibrium point, so that means y equals 1 meter. Or sorry, I probably should say y of 0 since it's the very beginning. Equals 1 meter. Given an initial upward velocity, so this is going to denote y prime of 0 is upward. So remember, as we said, in this case, we're given downward as positive. So upward means negative 2 meters per second. So that's definitely something you should watch out for, is where they denote as positive and negative, because in physics that really matters. So the next part, so for part A, now we have all our information. For part A, it says to determine the equation of motion for the system. So I'm going to go ahead and write out what our base equation is. Another thing to denote, it says no external forces applied to the system. So that means F of t equals 0. So we don't have to worry about anything on the right side when we do our equation of motion. Or sorry, our force equation. So first part is to get it all laid out, or for our dE. So 1/4 y double prime, because it's our mass times y double prime, plus b times y prime, plus k, which is 8 times y, equals our f of t, which I already said is 0. I'm going to rewrite that 8, looks a little funky. All right, so there's two different ways you can go about this to solve for your equation of motion. Equation of motion, that just implies y of t. So whatever our y is. But there's two ways you can go about it. For this case, we can either use Laplace transforms or solve for y of h and y sub p. I would say either is fine, whichever one you're more comfortable with. I like finding y sub h whenever, or y sub h, y sub p whenever, or like that form, whenever the right side is equal to 0, instead of solving for the Laplace. I think Laplace does have more algebra to it, meaning there's more chances for mistakes. But if you like Laplace better, I would still go ahead, go for it. But I want to solve for y sub h. So for y sub h, that means we need to get this into our auxiliary form. So I have 1/4 d squared plus 2d plus 8 all times y equals 0, which then implies r squared, so 1/4 r squared, plus 2r plus 8 equals 0. And if it makes it easier to look at, I'd multiply by 4 to get rid of that 1/4 out front, so it becomes r squared plus 8r plus 32 equals 0. So to solve for it, since I would assume that for an equation in motion, when we solve for our y sub t for this kind of problem, we're going to get sines and cosines. So I'm going to assume that this won't factor out easily, and looking at it, it doesn't look like it will. So we'll have to use the quadratic formula. So r1 comma 2 equals, so it would be negative b, which is 8, plus or minus the square root of b squared, 64, minus 4 times a, which is 1, times c, 32, so 4 times 32, which is 128. All over 2a, which is just 2. So this implies r1 comma r2 equals negative 4, plus or minus, we're going to have the square root of negative 64 here, so that would just equal ai. So we get plus or minus ai over 2, so plus or minus 4i. So in this case, we're looking at r1, r2 equals alpha plus or minus beta. Alpha equals negative 4, beta, to b, beta equals 4. And so when we write this into our equation for our homogeneous y sub h, then it will equal e to the alpha t, so negative 4t, times c1 cosine beta t plus c2 sine beta t. Oh wait, why am I putting beta? I should put 4. So one thing I didn't really think about that we do have to solve for is c1 and c2 for the equation, but that isn't too bad. All we have to do is plug in to the original function after we, because our y sub p equals 0 since we have nothing on the right side. So this is our y. c1 e to the negative 4t cosine 4t that's c2 e to the negative 4t. Oh man. So now we have our y of t. We could then use our initial conditions to solve for our c1 and c2. So y of 0, equals 1 meter. So that equals 1 meter. I'm going to take out that unit because we don't need units at this point. Alright, so then that will equal c1, and we plug in 0 for each t. E to the 0 goes to 1. Cosine of 0 goes to 1. Plus c2 e to the 0 goes to 1. Sine of 0 goes to 0. So this entire term goes to 0, which implies c1 equals 1. Y prime of 0 equals negative 2. So we solve for y prime real quick. So y prime, ooh, it's going to be a little tricky. So here, I'll move c1 down a little bit. c1 equals 1. So then y prime is going to equal, and we'll do one term then the next. So it'll be c1 times negative 4, so negative 4 c1 e to negative 4t, so this is the derivative of e to negative 4t, then times cosine 4t, and then plus c1, this will be 4c1 e to the negative 4t times sine of 4t. Ooh, that should be negative up front. So first term took derivative e to negative 4t, and the second term I took derivative of cosine 4t for the product rule, and then plus Next, we're going to do the other term, so we negative, actually minus. So minus 4 c2 e to the negative 4t sine of 4t. That would be taking derivative of e to the negative 4t on this term. And then minus, or actually plus c2e times 4 still. E to the negative 4t times cosine of 4t. Because I took derivative of sine. So now I want to use this equation and replace every t with 0 and equate it to negative 2. So we have negative 4 c1 e to the 0 goes to 1 cosine of 0 minus next term as a sine, so I'm just going to say that equals 0. And then next term as a sine, so that's going to go to 0. And our last term as a cosine, so be plus 4 c2 e to the 0 goes to 1 cosine of 0 goes to 1. This cosine also goes to 1. So then this implies negative 4 c1 plus 4 c2 equals negative 2, which implies 4 c2 equals negative 2. Say 1 is equal to 1, so we plus 4 times 1, which equals 2, which implies c2 equals 1/2. So I guess this is a drawback from using y sub h, just because there's this algebra here, but either way, you still get to the same answer. I'm going to make this move this up, make it a little bit smaller, so I can write down my final motion equation. So then this implies y of t equals c1, which is 1, e to the negative 4t times cosine 4t plus c2, which is 1/2, e to negative 4t times sine 4t. So that's your equation in motion. So none of this is really new in terms of how you get to your y. The only big thing is to remember what all your different little variables mean for your mass and how you plug it into your equation. Remember that this is m, b, and k. And let's then look out for your initial conditions. Sometimes you have to use your initial conditions to solve for k. So don't forget that. There's another problem like this in another video that may have that. So, but remember, equation of motion just means y of t equals whatever it happens to be. All right, so I'll move on to part B for this. So part B is find the equation in the form of yt equals a e to the alpha t sine omega t plus phi. All right, so a is going to be the square root of c1 squared plus c2 squared. And if you happen to have done the Laplace form, it would just equal the square root of a squared plus b squared. So whatever your coefficients out in front of your equation, so I'm going to use a different color. Blue. Actually, no. Actually, I'll do blue. So whatever is in front here, so C1 in this case is 1, C2 in this case is 1/2. So whatever's out in front of here from your cosine and sine will represent whatever you're squaring to get your form. Because when you do that, this also includes your, actually never mind, it does not include your e to the alpha t. That's right, so then this would equal the square root of 1 squared plus 1/2 squared equals 1 plus 1/4, which equals the square root of 5/4, which equals square root of 5 over 2. And I did that by putting the square root to the top and to the bottom. So that's my A. Now, my E, so my e to the alpha t is basically just my e to the negative 4 t. So that this pretty much comes from, it's just like the alpha transfers over. So that's where alpha equals negative 4. Just because in this case, alpha equals negative 4. And now for your omega is basically going to be equal to your beta. So since omega equals beta, this implies omega equals 4. Now your phi, it's going to be a little bit different. Phi is going to be a little bit more work. And there's a couple ways you can go about it and to solve for it. You can memorize certain equations. So you're going to say y of t equals e to the alpha t sine phi cosine omega t plus cosine phi sine omega t. And pretty much what this means is that C1, or whatever term is inside is for your cosine, your cosine coefficient. That term in this case is our C1 equals sine phi. And our sine coefficient, which is our C2, equals our cosine phi. So a good way to remember that is that your sine is whatever your trig function is, your coefficient will equal the opposite function phi. So cosine opposite sine phi, sine opposite is cosine phi. So and you just equate your coefficient to that to solve for it. So the actually, it's actually A. My bad. From my A here. So it is times your amplitude. But we don't need to worry about amplitude because we're going to solve for the way we solve for it. It cancels it out. So we always solve for tangent phi, which equals a sine phi over a cosine phi. Cancel out our a's. But that means it's going to equal C1 over C2, which is going to equal, let's see, C1 is 1 over C2, which is 1/2, which equals 2. And this implies phi equals tangent inverse of 2. So this applies that our y of t equals a, which is square root of 5 over 2 e to the alpha, which is negative 4 t times sine omega, which is 4 t plus phi, which we solve for is tangent inverse of 2. So this is our final answer. All right, do this last problem in purple. Now this asks, is the system underdamped, critically damped, or overdamped? So is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So from this term, the b squared minus 4ac, if this right here is greater than 0, then that implies overdamped. If it is less than 0, this implies underdamped. And if it's equal to 0, then it implies critically damped. In our case, since we had a negative in the radical earlier, because we did B, which was 8, 64, minus 4AC, 4 times 1 times 32, 128. That equals negative 64, which is less than 0. So that implies underdamped.